Okay, welcome to page 11a on level L. We're going to talk about logarithmic. First of all, we have to understand how do we properly read the logarithmic. So for example, if we see that log, you have the a and m. So how do we read it properly is we read it as log a as a base of m. Okay, so let's do it one more time. Log base a of m. So one more time, if we see this one, it should be log base 2 of 20. So that's how we properly read it. So before we move on to future pages, we have to understand the concept over here. So this tells me that when log base a of m is equal to x. So understanding how logarithmic work is that a to the power of what is equal to m. In that case, the x will be here. So really what happened is that a to the power of x should be m. So that log base a of m, it should be equal to x. So what logarithmic is trying to find out is that the base a to the power of what number will be equal to the m. That's how you will figure out, oh, this one is actually m, x, okay? So a to the power of x is equal to m, then log base a of m is equal to x. So the whole operation is trying to find out the exponent, basically, right? So once we know that, let's dive a little bit deeper, taking the logarithm to the base of b of both sides. So if we know that log b ax, and we know that a to the power of x is equal to m, right? So we know, okay, so log base b of m should be equal to log base b of a to the power of x. Then, according to the rule, we can take the x outside. We can take this x as exponent outside. So that's where you have the x outside. X times log base b of a is equal to log base b of m. That's pretty self-explanatory. Then we just divide the log base b of a to the right side, right? We just divide this side. We divide this part to underneath. So that's how you can get x is equal to log base b of m over log base b of a. As you can tell that this basically gives us the magic wand for us to change any logarithmic to the base, the same number, and I can add anything to the m or to the a. So giving you an example over here, okay? If we have log base 2 of 6, I can change it to the base of 10. I can change it to the base of 10, right? So in this case here, I can literally do log base 20 of 6 over log base 20 of 2. That's no problem. I can even change in log base of 100 of 6 or log base of 100 of 2, no problem. As long as the 6 and 2, they are corresponding to the original logarithmic, I'm able to conduct the operation. So given that knowledge, in each question we will have given, right? So given 10, log base 10 of 2 is equal to a, and log base 10 of 3 is equal to b. Write the following in terms of a and b. So let's see how we can work our magic over here. So let's take a look at question number 1. So question number 1 says that we have log base 2 of 20, right? And we wanted to find that we want this to change to something that looks like log base 10 of 2. So I will see that, okay, I have the 20 over here. So can I put the 20 over here first? And I have the 2 underneath. Can I put the 2 underneath? Then because my target logarithmic is log base 10, so I will do log 10 over here, and also underneath log 10 over here. As I mentioned before, as long as our top number, all right, the 20 and 2 will be the 20 and the 2 over here, we should be good. So similarly, if we look at question number 2, okay? So I'll pause the video a little bit and see that what we can do and what we can change. Okay, so what we can do over here, I can write the 5 over here, I can write the 3 over here, and then I can have log base 10 of 5, right? And then I can have log base 10 of 3. So we already know that log base 10 of 3 is equal to b. So this thing is equal to b. But I don't have anything that has log base 10 of 5. So how do I change it? So there are many ways that you can come up with the 5. But one of the easiest way that I think that we can definitely do is that what about we follow log 10, right? Log base 10 of 10 minus log base 10 of 2. And you know that according to the rule, we're actually dividing these two numbers together, right? If it's a subtraction of a log, we can divide these numbers together. So which means this is actually equal to log base 10 of 5. So again, this can be traced back into previous pages. There should be a rule over there where if it's a subtraction for a logarithmic, you can actually just do the division of the numbers 10 and 2. Okay, so giving that rule over here, I now know that log base 10 of 5 can be written as log base 10 of 10 minus log base 10 of 2, and the bottom will be log base 10 of 3, which I already know. Let me erase this part. If that's the case, and smart, you already know that the top log base 10 of 10 is equal to 1 minus log base 10 of 2. I already know that this is equal to a, so then 1 minus a over b. That would be the answer for the second question. So for number 3, let's pause a little bit and see that what we can do to kind of change things around to make sure that, you know, we have the log base 10 of 2 and log base 10 of 3. So I'll pause the video and then resume. So I come to a conclusion that I can still use the base 10, right? So then my first log base 2 of 3, I can write down the 3 here, I can write down the 2 here, times, I can write down the 4 here, I can write down the 3 here, and let's work our magic. So this will be log base 10 of 3. Underneath, I will write as log base 10 of 2. And then the second one, I can write down as log base 10 of 4 and also log base 10 of 3. And you can see that here and here we can cross it out because it just works like fraction multiplication. You can reduce across board. But what can I do with this one? And you know that 4 is actually equal to 2 to the power of 2, right? Oh, that's what I can do. I can change this log base 10 of 4 into log 2 times log 10 base 10 of 2. And then you will see that this one is log base 10 of 2, and this one also log base 10 of 2. I can cross it out. The only thing I have left is number 2. Okay? So hopefully that helps you understand exactly what it is for 11a, the concept we're talking about right here. And let's jump directly into page 12a. So on page 12a, as you can see, our target is log base 10 of 2 and also log base 10 of 3. Each of them is equal to a or b. So let's see what we can do. For the first one, log base 10 of 5. Okay, if I were to go with what I learned from the previous one, I know that 5 can be written as 10 divided by 2, which means that I can literally have log 10 base 10 of 10 minus log base 10 of 5. Of 2. In that case over here, since I already have log base 10 of 2 is equal to a, and log base 10 of 10 is just equal to 1, so the first question will be just 1 minus 2. Pretty easy, right? All right, number 2. What I want to do for the 12, again, a couple ways. But since I already have the base as 10, I wanted to see that if I can do log base 10 4 plus log base 10 3. Because according to the rule before, if I add two numbers together, I can actually just multiply the top part, 4 and 3 together, which gives you the 12, right? So this is actually equal to log base 10 of 12. So then this one here is just simply log base 10 2 to the power of 2, which can also be written as log 2 log base 10 2 of 2, and plus log base 10 of 3, and this will be equal to, this one already know, it's basically 2a, and this is b. So the answer will be 2a plus b. So for this one, 2a plus b. I can erase all the. Again, the answer book does not show the detailed steps one by one, so I'm breaking it down so then you guys will know that exactly how I get to these functions, okay? So number 3, I have log base 2 of 3. Okay, I need tens, right? So I put a 3 here, I put a 2 here, log base 10 of 3 and log base 10 of 2. And it's pretty self-explanatory. I have the b on the top and a at the bottom. So number 4, all right. So what I want to do first, I don't have any base 10, so I want to create a base 10. So I have the 5 written down here and 2 written down here, log base 10 and log base 10 over here. And according to before, I already know that this is going to be 1 minus a, right? According to question number 1, I can just use it, all right? Be smart on that. And the next one, I know that log base 10 of 2 is just equal to a, so the answer will be 1 minus a over a. All right, next one might be a little bit tricky. So first, let's change it into something that has the base 10. So log, all right, so 18 here and 6 over here, log base 10 and log base 10. So what I want you guys to do is pause the video for a little bit and see that how you can come up with the 6 and 18. There's a couple ways again. So I want to kind of wait for you guys and then get to that point. All right, so once you guys are done, let's dive right back into it. So 18 is basically 2 times 9, right? And which this 9 is basically 3 to the power of 2. So if I were to break this log base 10 and 18 down, that would be log base 10 2 plus log base 10 9. At the bottom, similar concept, log base 10 2 plus log base 10 3. Okay, so you already know that this and this is a and b, right? And b, so this is a plus b on the bottom, so I already have a plus b at the bottom. Over here, this is still a, right? This one is a. How about this one? Smart you, let's get it done. So this one is actually log base 10 3 to the power of 2, where I can actually move the 2 outside. So this will become 2 times log base 10 of 3. So which means that the top will be a plus 2b. Okay, alrighty. Next question. Oh, I see fraction over here, but don't be scared of fractions. We will have 8 over 9, and this will be 18, right? Still, I don't have the log base of 10, so I want to create the log base of 10 first and see that if there's anything I can do. Okay, so now I have log base of 10 of 8 over 9, and this will be log base of 10 of base 10 of 18. The bottom part I learned from my previous question is just equal to a plus 2b. I don't have to do any more calculation. It's the top part that becomes a little bit tricky. So why don't you guys, again, pause the video and see that how you can come up with 8 over 9 in this case. Again, according to a rule, a log subtract another log you can perform the division on the top number, right? So once you pause the video, when we come back, you will know that this one would be log base 10 of 8 minus log base 10 of 9, right? That's how I come up with the 8 over 9, basically 8 divided by 9. And this log base 10 of 8 can be rewritten as log base 10 of 2 to the power of 3, where you can actually move the power of 3 outside, minus log 10 base 10 of 3 to the power of 2, where you can also move the 2 outside. So this will become 3 log base 10 of 2 minus 2 log base 10 of 3. And you already know that log base 10 of 2, this will be A. And then log base 10 of 3 will be B. So that's how we write down 3A minus 2B. And at the bottom is the same number, A plus 2B. Okay, so on page 12B, we have a little bit example over here. Again, this one we have to also use the previous knowledge as well. We have log base 2 of 3 is equal to A. So watch this, okay? This one, the base is 2 now, right? And also we also have log base 3 of 7 is equal to B. Write the following in terms of A and B. So for this page, what I want to do is that I would only explain to you guys how to do the example. And I want you guys to kind of try question number 1, 2, and 3. So question number 1, actually example, my bad. So we have this, and we also have 21 here, we have 6 over here. So my first goal is that, okay, how can I conduct and how can I change my things, my logarithmic around so then it can fit the log base 2 and also the log base 3 kind of concept over here. So the first one, I will see that I have 21, I have 6, so let's work with base as 3 to see that what I can do first. So if I change this one into log base 3 of 21 and log base 3 of 6, obviously you can also change into log base 2, 21, and log base 2, 6. It doesn't matter. It's basically the other way around, right? Because you want to find out the base that's the same with the target logarithmic. Okay, let's work on the first one here. So once we have log base 3, 21, and we have log 3, base 3 of 6, I can first change this log base 3, 21 into log base 3 of 3 plus log base 3 of 7. That's how you get the 21. And you know that the log base 3 of 3 will be equal to 1. That explains how we're getting the 1 plus log base 3 of 7 over here, right? That's how you get that. And similarly, with the log base 3 of 6, we can change into log base 3 of 2 plus log base 3 of 3, which this will be 1 as well. So use the 1 strategically. In this case, if you have the base and the off number together, they're the same, you can always use 1. So on the top, nothing changes. On the bottom, however, I wanted to create something that involves the base 2. So according to the rule before, log 3 base 3 of 2 is actually equal to 1 over, basically the reverse number, log base 2 of 3. So in a nutshell, log base A of B, it should be equal to 1 over log base B over of A. So the numbers got reversed, right? As you can see. So this is, again, another rule that was introduced previously. So that's how I can change the log base 3 of 2 to 1 over log base 2 of 3. So hopefully this makes sense to you guys. So first of all, we know that log base 3 of 7, according to our explanation or target logarithmic over here, this is equal to B. So that's how I get 1 plus B. And then at the bottom, we know that log base of 2, log base 2 of 3 is equal to a, so that explains why we get the 1 over a. And then I would multiply both sides by a, right? The top side by a, and also the bottom side by a. Why do I do that? Because I don't want to deal with the fraction at the bottom. If you leave it like that, it's called partially right. We also have to simplify it, right? Once we simplify, the top will just become a plus ab, and then the bottom will become 1 plus a. Hopefully this video helps you guys understand the basic rule of logarithmic, and then you'll be able to do and conduct the other operations. Thank you so much.